this one. So let g of x equal this integral from 0 to x, and no, it does not. A does not have to be 0. Where f is the function whose graph is shown, so this is f. Evaluate g of x for all of these things. All right, this starts at 0, right? So what is g of 0? Yeah, right. And it's not because it's a 0, it's because it doesn't move, right? So from 0 to 0, you're not moving, so your area is nothing. G of 1 means what's my area from 0 to 1?
1/2.
Yay. G of 2.
0, 0.
Good. Because those two triangles have the same area, but one's positive, one's negative. They canceled each other out.
-1/2.
Awesome. Colin's on a roll.
0.
Yeah. And then, yeah, Bobby got it.
1.5.
Yeah. I can't even write as fast as you guys can get the right answers.
2.5. 4.
Is it?
4.
It's 4.
Oh, because you add 2.5 on. Yeah, 1.5 plus 2.5.
And then that
what
funky thing.
is that?
Oh, we're only going to 6.
Oh, estimate G of 7.
Oh, tricky.
I'm
I'm
gonna
gonna
go
guess-
with
You know I'm singing White Chicks.
No.
Chick it, chick
Like 2 and a quarter.
2 1/4.
2 and a quarter.
it.
I'm gonna guess 3.5.
Sure.
Plus
1, 2.
4.
Yeah, and you guys could guess whatever you want because I heard 2 1/4 more than once, and I.
We've added up 4.
Let's go.
Yeah, and you're adding that on to the
Let's
Give
4.
us 7.5.
So any of these are fine, right? I mean, we're adding it onto our last one. So whatever you guys decided to add on to it, it's fine. You're estimating. Okay? We all good? All right. Where does G have a maximum value, and where does it have a minimum value? And then we're going to generically, like, make this easier. But, I mean, can you see where it has its max and its min?
6 and 3.
Well, kind of 6, but
6 and 3.
Wait,
because
what?
-1/2.
Oh wait, the
What about-
maximum of the area.
What about 0, 2, 4 as the minimum?
okay, so it's maximum.
Oh wait, no, there's a negative.
Yeah.
It's 3.
3
3 is your
-1/2.
minimum.
And 6.
Yeah, 3 and 4.
Here's the
3
minimum
and
6 or
6.
7 technically.
6
would be.
and a half.
Okay, so, right, it's got its absolute maximum at 7, right? Yes. And did it have any little relative minimums or maximums, you're saying?
1.
Yes, at 1. So I boxed that one in because that's the absolute maximum. This one was a little local maximum. And where was our min?
And 3.
3.
Yeah.
And that's local min. Absolute.
Okay, so we had a local max, a local min, an absolute max. Sketch a rough graph of G.
Oh, this is gonna be interesting.
Okay, so I'm going to do all these values as points in orange on the graph. This is why if you, no, it's not free anymore. It's because if you open this up in Notability, you can just draw right on the graph.
Well, yeah. Well, are you going to upload this as like a PowerPoint or notes or something onto Headlines? Or is it just the video?
Huh, yeah, I'll do that.
Okay.
Okay, because that helps you, because then
Yeah.
you print them for your binder. Okay, G of 0 is 0, G of 1 is a half, G of 2 is 0, G of 3 is negative a half, G of 4 is 0,
1.5.
G of 5, G of 6, and then G of 7, which we said it's up here somewhere, right? Okay,
So
so
that's the graph of the integral.
this is the graph of the area so far function. Yes, of the integral from A to x, right? Depending on your x.
Depending on where you are.
Okay. So, in general, can you guys tell me, without having to make a whole sketch and without having to do a whole table of values, how can you quickly, when you just are looking at a function like this, realizing this is an area so far function, can you tell me how to easily find where it's going up or where it's going down, or, kind of just by looking at the purple shaded part?
where the tangent.
Yeah,
of the,
basically.
wait,
I'm going to stay away from the word tangent
Yeah,
because
as
I
long as
want to
we're crossing
concentrate on the
X-axis.
yeah, right? Because all this area is positive. So even though my function's getting smaller, that's why I don't want to look at slopes. The fact remains that you keep adding on area until you get to that 0. So you're going to have a max when you cross that because from that point on, then you're going to start to subtract area away. So your maximum has to occur right there. Okay, it's not just because of the different values that we chose. Like, that was it. That was where your maximum was going to occur. And then you were going to keep subtracting area away until you got to here. And once you got here, you were going to start adding on area again. So this is most definitely going to be your minimum, right? Because that's when you start to add area on again. So realizing, always keeping in mind that this is just an area, an accumulation of area, an accumulation of stuff. Sometimes it's other things like oil, being put into something or sand or whatever. But so your accumulation, where it's above the x-axis and then it switches to below, you're going to have a maximum. And where it goes from below to above, you're going to have a minimum. There's that. But I just want to look at this last problem over here, okay? Let's just take almost the same problem we had before. Sine of t dt is just a little simpler. Just to realize, okay, what is going to be the difference if I want to find g prime of x for this problem? And I can't just throw in a 3x squared. I am going to, but I'm going to have to do one more thing, okay? So let's think back to the chain rule.
Just ask you on the outside.
You have
Kind
to-
of, sort of.
You have to do the derivative part.
I was thinking running in. Did you say the
Yeah.
derivative of the 3x squared?
Squared.
Mm-hmm.
Yeah.
Is it somehow just intuitive to you guys? You are. You're going to just be multiplying by the derivative of 3x squared. Here's why. Because if I think of that, let me use these two colors, as if I think of that thing as a u, okay, then what I can do by like applying the fundamental theorem of calculus part 2 is I can differentiate this with respect to u. And it tells me just to throw my u in, right? But now I've kind of altered the problem a little bit. So if I want to take it back to not altered anymore, then I would say, oh, well, if I multiply by du dx, then I really have found the derivative with respect to x of that function. So that's why it works. All right, so yeah, g prime of x is just going to be, you plop the u in right there, and the u is 3x squared, right? And then you multiply by du dx. That's it.
Oh, okay.
Not bad at all.
Makes sense.
So really, you were doing this in the fundamental theorem of calculus part 2, but the derivative of x is just a 1, so there's just always a 1 there. Chain rules always make sense in the most general case where you don't think about chain rule.
Yeah.
Where is Marissa? We hope you feel better. Say bye. Bye. Guess I don't always have to do that, huh? Make everybody dizzy at the end of every video.